In the kinetics, correct, Yazira, even Parikshit gave somewhat correct answer, speed. Okay, good evening, Hari Mahesh. Speed. Okay. Over here in this chapter, what are we going to see is the speed, or what we call as a motion. That is basically rate of reactions. What we are going to study is the rate of the reaction. Rate means how fast or how slow your reaction is happening with respect to time. Okay, how fast or how slow the reactions are happening with respect to time. That is what we are going to study in this chapter. Very easy. Again, I'll repeat, very easy chapter. Very scoring chapter. Do not miss marks over here. Very scoring chapter. Okay. So if you look at the reactions, okay, different type of reaction. There are various types of reaction. Okay. So in the reaction, in the chemical reaction, what are the different things that we study? So over here, you can see speed of the reaction. Yes, speed of the reaction is what we are going to study, how fast the reaction happens, and with respect to speed, what affects the speed of the reaction, what affects the rate of reaction. Catalyst, does it affect the rate of reaction, everyone? Will catalyst determine whether your reaction will go fast or slow? Yes, it does. Yeah, correct, Yazira. Yes, catalyst will affect the speed of reaction. Will temperature affect the speed of reaction? Yes, everyone. I hope you are getting it. Yeah. Yes, even temperature will affect the rate or the speed of the reaction. So in the chemical kinetics, we study a specific type of reactions. Like if you compare the reactions, there are reactions which are very fast. Fast reactions. Can anyone give me example of very fast reaction? Which reactions are very fast? Can anyone tell me by logic? Very fast reactions. Yeah, very fast reactions. Potassium plus cold water. Okay. What else? What else? Very fast reactions. Think about it now. Fast reaction, or we also call it as an instantaneous reaction. What we call it as a instantaneous reaction. Burning of inflammable gas. Okay. Mentos in Coca-Cola. Instantaneous means it does not mean Vishwanath. Instantaneous, it does not mean that it will happen after 2-5 seconds. Instantaneous means micro millisecond. Burning of magnesium ribbon. Okay. See, to cut story short, which reactions will happen fast? That is your ionic reaction. Generally, your ionic reactions will happen fast. Why, everyone? Why ionic reactions will happen fast? Why ionic reactions will happen fast? Yeah. Why ionic reactions will happen fast? Because they split. So what? See, because when you form ions, you have a positive and negative charge. Okay. And obviously, whenever you have charges, those reactions happen faster. Okay. Even your neutralization reaction, yes? Even your neutralization reaction. What is a neutralization reaction, everyone? What is a neutralization reaction? Can anyone tell me? Yeah? What is a neutralization reaction? Come on, tell me. Must have heard about it. Neutralization. Neutralize, I know. Neutralization, it neutralizes. Correct, correct Parikshit, correct Vishnu. Correct Akash. Yes, come on, give me example of a neutralization reaction. No, apart from 3. Yes, Yazira. What is the neutralization reaction? Muttu, Vishnu. Vishnu has given the answer. Shrutika. What is a neutralization reaction? Yeah. What is the neutralization? Correct. Acid plus base. Yes, we neutralize acid and base. So acid plus base reactions are nothing but neutralization reactions. So when you react acid and base, what you get is a salt and water. What you get is a salt and water. So again, this is nothing but a very fast reaction. Okay, this is nothing but very fast reaction. So this all reaction we do not study in the chemical kinetics. We do not study. Those are very fast. Okay, they happens in like instantaneously in 10 to the power minus 2 seconds, 10 to the power minus 12 seconds. We cannot find out the rate, we cannot find out the speed. It happens immediately. So we study moderate reactions. What do we study? In the chemical kinetics chapter, what we are going to study throughout the chapter are nothing but your moderate reactions. Moderate reactions means what, everyone? It is neither fast, okay, it is neither slow. It is neither fast, it is neither slow, it is moderately speed. Okay, it is moderately speed. Okay, so for example, come on, write down the examples of moderate reaction. Decomposition of hydrogen peroxide. Come on, tell me first of all, what is hydrogen peroxide? Yes, everyone. Akash, Vishwanath, Noel, Hari Mahesh, Muttu, Vishnu, Netra, Sai, Yazira, Shrutika. Hydrogen peroxide. Yes. Correct, Parikshit. Correct, Vishnu. Correct, Hari Mahesh. Yes. Hydrogen H2O2. Hydrogen peroxide is nothing but H2O2. So if I decompose H2O2, decompose means what? I am breaking down H2O2. What do we have in H2O2? Yes, we have water and oxygen. We have water and oxygen. Come on, balance this reaction. Balance the reaction quickly. I am not helping you in the balancing. Come on, balance the reaction. So over here, how many hydrogens we have? Hydrogen is balanced, but 2. I'll multiply this by 2. So if I multiply this by 2, oxygen 4, over here 2, 2H2. Good evening, Srushti. Why you are late? Wow. Oh my God. You drank, everyone. If you can see the reply of Hari Mahesh, he drank the hydrogen peroxide. Oh my God. Oh my God. Oh my God. It is acidic. It might, your insides might burn. Hari Mahesh, how can you drink it? It might be very, very dehydration. Okay. Then even your decomposition of your nitrogen pentoxide. Yeah. Tell me something over here. N2O5, it will decompose into what? Everyone. N2O5, it will decompose into, yes, N2O5, it will decompose into, yes, N2O5, it will decompose into, I have given you hint by balancing the reaction. I am saying decomposition. Again, decomposition, oxygen gas will be evolved. Yes, oxygen gas will be evolved. And what you get is N2O4. Okay, so such type of reactions like decomposition of reaction, then your the reaction that is happening of cane sugar, yeah, cane sugar to glucose and fructose, that is also moderate reaction. So all this reaction is what we study. All this reaction is what we study in the chemical kinetics. All this reaction is what we study in the chemical kinetics. Okay, now let us understand what is this rate of the reaction. We use this word so many times, and you'll hear this word so many times in this chapter, you have no idea. Rate of a chemical reaction. Rate. Can you show previous page for a minute? Just a minute. Rate of chemical reaction. Rate of chemical reaction is what we are going to study. Okay, write it down if you have not written, everyone. If it is done, tell me done. Done, done, done. Okay. Now look over here. When I write down everyone, reactants give me product. Okay, reactant is giving me product. So over here, reactant is giving me product, so I have to write down the rate. Okay, I have to study the rate of the reaction. Now, first of all, what is rate? Yes, what is rate? Rate is something that we study with respect to time. Rate is something that we study with respect to time. Now, as the reaction starts, I want everyone's focus on the screen. As the reaction starts, what happens? Your reactant initially is very, very high. Your reactant initially is very, very high. But I am talking about concentration, okay? But as the time starts, slowly, the concentration of reactant goes on decreasing, and the product goes on increasing. For example, over here, everyone over here, look at this graph. Over here, look at this graph. Now, over here, this is the time, okay? This is the time, and this is the concentration, okay? This is the concentration, 1 molar, okay? This is the concentration. Now, over here, everyone, over here, what is happening? Okay, over here, this is 1 molar concentration. Actually, it is C4H9Cl. C4H9Cl. Okay. So what is happening over here? Initially, at time 0, the reaction has not yet started. The reaction has not yet started. Okay. So initially, the concentration will be very, very high. The concentration of the reactant will be very, very high. But as the time passes, everyone, what will happen? Look over here. This is more accurate. If I am talking about reactant, as the time passes, what will happen, everyone? Concentration of reactant increase or decrease? As the reaction starts, concentration of reactant, will it increase or yes? Correct. It will go on decreasing. That's why in the graph you can see, with respect to reactant concentration and time, you can see it is decreasing. It is decreasing. Okay, it is decreasing. And after certain time, this actually goes and becomes straight. That means an equilibrium has reached. Similarly, over here, everyone, you can see over here the product. Okay. Initially, what will be the concentration of product at time 0? At time 0, what will be the concentration of the product? Yes, at time 0, concentration of product will be 0. That means the reaction has not yet started. Since the reaction is not started, the product will be 0. Okay. But again, on the x-axis, time is there. Time is going on increasing. So if you increase the time, the reaction starts. As the reaction starts, what will happen to product? Will it increase or decrease? Yes, everyone. Correct, Srushti. It will go on increasing. Okay. Today is the introduction of the chapter, so do not feel that we are doing very basic. It is there in your syllabus. You have to do this also. Okay. It is go on increasing, and finally, what will happen? It will also become constant. Is it clear, everyone? Yes? Is it clear? Yeah. So if I combine these two graph, I can draw a graph like this. Look over here. If I combine these two graph, okay, you tell me what is the reactant, what is the product. If I combine these two graph, suppose this is my one axis, this is my time, okay, this is concentration. Okay, so I can make one graph over here. Yeah, let us say A, let us say B. Tell me which one is the reactant. A is the reactant or B is the reactant? In your given graph, A is your reactant or B is your reactant? Yes, everyone reply in the chat box. Yes, A is reactant or B is reactant? Yes. Again, this can come similar type question. Yes. So over here, B is reactant. Why? Because initially the constant, as the time passes by, the reactant is slowly getting converted into product, and hence reactant concentration is decreasing. But when we talk about product, initially the product is not yet formed. The reaction is not started, but it goes on increasing, increasing, increasing. Is it clear, everyone? Yes or no in the chat box? Is it clear? Is it clear, everyone? Okay. Now look at this graph. So there are two types of rate. No, they will stay parallel. They will stay parallel. They will not meet. That is what I am saying. No, the rate with respect to the concentration, it will stay constant after some time. That is when you know that equilibrium is reached. When they stay in the constant, that you know it is equilibrium is reached. Equilibrium is reached. Okay, over here, you can look over here in the graph. There are two types of rate given. Okay, there are two types of rate given. That is, one is your instantaneous rate. Okay, one that is instantaneous rate, and one which is an average rate. Okay, one is an average rate. Okay, now if you remember, I told you the difference between the small d and capital D. Yes, what is the difference? Small d and capital D. What is the difference, everyone? What is the difference? Small d and capital D. Yes. What the small d indicates? Correct, Parikshit? Yes. Muttu? Yes. Sakti? Yes. Netra? Yes, Zira? Small d indicates what? Both are delta. We call both them as delta. But what is that small d and what is that triangle? Come on, tell me. What is that small d? What is that capital D? Yeah? No? Come on, my physics people. You should know this. What is it? What the small d indicates and capital D indicates? Obviously, both of them indicates change. But what is the difference? Then I can use the d everywhere. I can use the delta everywhere. What is the difference? What is the difference? We are not talking about d by dx, Vishnu. What? Where are you going in the maths? I'm just asking you. Yes. Over here, d is for very, very small. Not only small, it is infinitely small. It is infinitely small changes. Okay. Infinitely small changes. Okay. And over here, this we use for the finite, like the difference between 2 and 4, 8 and 6. So that is for what we use the delta. That is for your little bit of larger numbers. Okay, little bit for your larger numbers, for the greater change, for the greater change. So over here in the graph, you can see average weight. So average weight is calculated from 2 points. Over here, I'll draw it with another color. Look over here, over here, over here. From this, you have got average weight. Again, over here and over here, you have got average weight. But instantaneous rate, everyone, see, look over here. P instantaneous written, that is R instantaneous actually. R instantaneous is this point. Okay. At this point, what is the rate? At this point, what is the rate? Is it clear, everyone? Is it clear? Okay, Srushti, I'll repeat. Look over here, everyone. So there are two types of rate. Write it down. Srushti, one is your instantaneous. I'm again going to write it down. Instantaneous, yes, and second is average. Okay, so for instantaneous, Srushti, we use D. That is very small change. Average, we use delta. Average, we use delta. That's what you are taking on a range. That's why over here, the average rate is given. That is, they have considered 2 points. I'll explain you the values. Do not worry. But for now, understand how to read the graph. Okay. Over here, the 2 points are given. If you take the values of that, you'll get the average value. You'll get the average rate. And if I select a particular point, not only this, I can select this point. I can select this point. The whatever point I like. Okay. That will give you instantaneous rate. That will give you instantaneous rate. Is it clear, everyone? Yes or no in the chat box? Is it clear? Okay, and therefore, everyone, I can say that, look over here. With respect to reactant and product, I can write the rate. Okay. Now, what is the meaning of square bracket, everyone? What is the meaning of square bracket? Yes. What is the meaning of square bracket? What is the meaning of square bracket? Correct, Vishnu? Correct, Jyotsna? Parikshit, where are you going into the maths? I am talking in chemistry. Yes, correct, Yazira. It is the concentration, Parikshit. What? It is the concentration. Okay, square brackets are for your concentration. Now, over here, you have, let us say, with respect to time, you are calculating the rate. Okay, with respect to time, you are calculating the rate. So, del T will be equal to what? T2 minus T1. So, you will check from initial position to the final position. What is the difference? From the initial position to the final position, what is the difference? For that, we are here. Okay. Now, similarly, I can write delta R. Yes or no? I can write delta R. Yeah. So, delta again. Delta, what I can write? Delta R is equal to again R2 minus R1. R2 minus R1. Correct? And similarly, I can write delta P is equal to P2 minus P1. Delta P is equal to P2 minus P1. Correct? So if I have to explain this, it will be what? Rate of disappearance. Everyone write down in the book, important formula. Rate of disappearance. Rate of disappearance of reactant. Rate of disappearance of reactant. Rate of disappearance of reactant will be equal to what? That is how much your initial concentration is decreased with respect to time. Decrease in concentration of R, decrease in concentration of R with respect to time. With respect to time. Now the question is over here, this value is given as the minus delta R by delta T. Minus delta R by delta T. So students over here, come on, tell me by delta T. Now the question is, everyone, why there is a negative symbol? You do not ask my question to me. I am asking you why there is a negative symbol. What decreases? Opposite in direction. So what? Decrease in the concentration. Concentration of reactant decreases. Is it? What is happening over here? Why it is minus? Why it is minus? Because over here we can write, very good, Noel. Very good. Very good. Yes, to make the value positive. Now look over here. Everyone, please focus on your screen. Suppose I have any value over here. Let us say I have value 100. Okay, I have drawn a graph. 100 to 0 are my value. Okay, 100 to 0 are my value. So let us consider two values, that is 60 and 30. Okay, or even if you take the reaction, if I am going from A to B, okay, if I am going from A to B, if I am going from A to B, let us say I have 100 molecules. Let us say I have 100 molecules initially, B does not have anything. But the reaction went ahead, only 30 are left and 70 are gone. Okay, 30 are left, 70 are gone. Now in this case, everyone, if I take the delta, what will be the change? Yes, what will be the change for the reaction AB? Everyone, come on, find it out. I hope everyone is getting it. See, look over here. What are we doing? What are we doing? We are doing delta means what? Initial minus final. Initial minus final. That is the formula of delta. We all know initial minus final. So over here, your initial value is 30, final value is 70. So if I do 30 minus 70, what is the answer you are getting? You are getting minus 40. So to ignore the value, the rate, to ignore the change in negative, we write minus over here. So that minus minus becomes plus. Minus minus becomes plus. Is it clear, everyone? Yes or no in the chat box? Is it clear? Come on, write this down. Just for the example, write it down. Muttu, is it clear? Come on, write it down as an example. Noted? Yes. Okay. So over here, if I am talking about reactant to product, if I am talking about reactant to product, so can I write it like this? Look over here, students. Sorry. Look over here, students, carefully. Can I write it like this? Minus delta R by del T. Minus delta R by del T. Yes, minus delta R by del T. Come on, write it down, everyone. Those who have not written. Minus del R is equal to del T. Yes, with respect to product. Yes, with respect to product. How are we going to do with respect to product? Let us say I have P, that is del P. Again the same thing. Again the same thing over here, students, isn't it? If I have del P, okay, so again P2 minus P1. So over here, do we require a negative charge? Think about it. Think about it. Over here, do we require a negative charge? Do we require a negative charge? Yes? No, we do not. Why? Because if I take the del P by del T, yes, it is already final minus initial. It is already final minus initial. Forget about everything. Just look at the logic. No, just look at the logic. Yeah. Initial value, let us say I have taken again 100. Final value I have taken as 20. Yes. Because it is going on decreasing. Yeah. The product, is it decreasing? No. Final value will be higher. It is going on increasing. So let us say initially let us say I have 20. Okay. So slowly it goes on increasing. Yes. Let us say 80. Okay. Initially means I am talking about certain time. Okay. Let us say 2 minutes. If I take it very initially, it will be 0. If I take it very initially, it will be 0. Okay. So if I do P2 minus P1, I am getting a positive value. So I do not have to multiply by negative sign. Is it clear, everyone? Is it clear? Okay, so can I write it like this? Rate of appearance is equal to yes, del P by del T. Rate of appearance, write it down. Rate of appearance of product is equal to rate of appearance of product is equal to del P by del P by del T. Is it clear, everyone? Yes or no in the chat box? Is it clear? Yes, this is what we just discussed. R by P del R R2 minus R1 del P P2 minus P1. Yes, if I substitute that, this is what we have got. This is what we have got. That is minus del R by del T. Yes, minus del R by del T is equal to plus del P by del T. Plus del P by del T. Okay, let us come to the important part. Rate of chemical reactions. Yes, rate of chemical reaction units. Come on, let us go ahead. So units of rate. What is the unit of rate? Yes. Now there is nothing exists as first rate, second rate. There are orders. Okay, there are orders, but the rate, unit of rate will be what? It is concentration with respect to time. Come on, write it down. Concentration with respect to time is nothing but the unit of rate. Concentration with respect to time so we have to use the SI unit. If the concentration, everyone please be careful, write it down in your book. If you are using SI unit mole per liter, then second you have the time you have to use as a second. Yes, the time you have to use it as a second. Come on, note it down everyone. Come on, note it down. Done in the chat box. Come on, done in the chat box, everyone. Okay. Done. Now look over here. These are some of the rate. Do not study now. I'll teach you when we do the numerical. Let us see what is this instantaneous rate and what is this. Yes, after instantaneous rate, what we have is the rate of chemical reaction. Rate of chemical reaction. Okay. So instantaneous rate, everyone, as the name suggests, instantaneous rate. What do you mean by instantaneous? Yes. What do you mean by instantaneous, everyone? What do you mean by instantaneous? Yes, Vishnu, Jyotsna, Srushti, Parikshit, Muttu. What do you mean by instantaneous? Instantly occurring in very small interval. Yes, correct. Instantaneous means it happens immediately. Instantaneous means it happens immediately, and we use the D over there, the small d. Yes, we use the small d. That's why over here you can see rate of average is equal to average rate is equal to minus del R with respect to del P is equal to del P by del P is equal to del P by del P. Is it clear till over here? Everyone, is it clear? Come on, yes, in the chat box. Is it clear? Till over here, is it clear? Any doubt till now? Is it clear? Vishwanath, Shrutika. Okay. Now, one thing, always make sure that whenever you write down the reactant side, it should always be negative. Reactant side, you have to do the negative. You have to do the negative. Please write it down. Reactant side, you have to do the negative. What do you mean by that? Look over here. Average rate is equal to minus del R by del T. Similarly, over here, it is not reactant. That's why nothing is written. Is it clear, everyone? Reactant side always and always minus R. Okay. Sure. So over here, everyone, if I write the instantaneous reaction, as I told you, what I'll use the small d. I use the small d. So for the reactant, you can see it is negative. For the product side, it is positive. Same thing over here. Average rate, that is negative. This is positive. Okay. Now you might have numericals on this. Probably it won't come. You have much to study. Okay. Now next after this, yes, rate of chemical reaction instantaneous. I'll come to this graph first. Let us go ahead. Okay. Now look over here. Very, very important. Look over here. Instantaneous and you can say average also. Okay. Instantaneous, average, both we have included. Now look over here. How to write down? Now the question can come. Write down the rate of a chemical reaction. Write down the rate of a chemical reaction. Now remember one thing, everyone. Remember one thing, always and always. Okay. The rate is dependent on what is the concentration of the reaction. Okay. Whenever you have to study any reaction, you have to first look at the reactants. Always and always, you have to make this as an habit. Whenever you do a reaction, first what do you do? First thing that we do is we check the reactants. Okay, we check the reactant side. Now over here, the rate of reaction, everyone, is dependent on the reactants. So if I have to write down the rate of reaction, how will I write? Del Hg by del T. Okay, del Hg by del T. Okay, that is change in concentration of Hg with respect to time. Obviously negative because it is on the reactant side, is equal to, over here it should be plus, is equal to minus del Cl2 by dt. Minus del Cl2 by dt. Is it clear, everyone? Is it clear? Yes or no in the chat box? Is it clear? Only one yes. Yes, everyone. Vishnu, Hari Mahesh. Okay. Okay, so write it down for the reactant. Okay, rate of reactions will be this. Okay, and over here you will get one product. You will get one product. Okay, so for product it will be positive. For product it will be positive. Is it done, everyone? Come on, done in the chat box. Okay, now write it down for this. 2HI decompose. Over here it should not come. 2HI decompose to give you H2 plus H2. Come on, write it down. Write down. Yes, everyone. Write it down. So rate of reaction for a second question. Now look over here. Okay. Whatever, first of all, reactant will always, yes, reactant will always be positive, yes or no? Yes, the reactant will always be positive, yes or no? Yes, the reactants will be positive, no? No, the reactants won't be positive. Yes, the reactants are negative. Please turn on your camera, everyone. So over here, yes, it is minus del Hi minus del Hi by del T, and students, and whatever coefficient you have, you write it over here in the denominator. This is nothing but your rate of reaction. This is nothing but rate of reaction. Is it clear, everyone? Yes or no in the chat box? Is it clear? If it is on the reactant side, negative will come. If it is on the product side, positive will come. Yes? I hope it is clear. Yes, and the coefficient, write it down in bold. Coefficient will always and always be the reciprocal of what we have. Coefficient will be the reciprocal of what we have. Coefficient will always and always be reciprocal. Go and write it down and tell me done. Sir, then H2 also should be negative. No. Over here the reaction is, Srushti, the reaction is 2HI giving you H2 plus I2. Okay, and H2, I2 are your products. H2, I2 are your products. And this is your reactant. Okay, so product will be positive, reactant will be negative. Okay. Now those who have done it, okay, I'll give you the next reaction. So you do it on your own now. do it on your own. 5Br minus, 5Br minus, or write it like this, 5Br minus over, okay, no, first let us write down the reaction. Look over here. 5Br plus BrO3, 5Br plus BrO3 plus 6H plus, yes everyone, it gives you what? It gives you, yes, what it will give me? It will give me bromine. It will give me bromine and water. It will give me bromine and water. It will bromine. It will give me bromine and water. It will give me bromine and water. Okay. Now come on. Write down the rate of reaction for this. Write down the rate of reaction for this. Yes. With respect to each of them. Come on, write down the rate of reaction for them. Write down the rate of reaction. Always and always remember. Okay. So I'll help you with this one. Okay. Always and always remember, all of them are equal. Okay. All of them are equal to each other. You can compare anyone with anyone. Okay. Just like your mole concept. You can compare it with anyone to anyone. For example, the first one, with respect to Br minus, if I write, rate will be equal to what? Come on everyone, tell me. Rate will be equal to change in, should it be positive or negative? Yes, Rushti, Azira, Parikshit, Muttu, Dharneshwar, Noel, Netra, Sai, Jyotsna. Should it be positive or negative? Yes, since it is on the reactant side, it is negative. This coefficient, everyone turn on your cameras please. The coefficient will be what? Yes, correct, Hari Mahesh. It will be minus 1 by 5. Yes, and whatever you have will be equal to del Br minus, yes, del is equal to, again go on. Again, this is on the reactant side. Yes, this is on the reactant side. So can I write it like this? Minus, okay, there is no coefficient, so 1 stays as 1, del of BrO3 minus over del 2 over del 2. Come on, continue like this. Can you see my note? No, Jyotsna, I cannot. Come on, continue like this. I have written bromine, BrO3 minus. Come on, 1, 2, 3. Okay, Noel, just a minute. Let me check. Okay, very good, Noel. Okay, perfect. Just a minute, Jyotsna. Okay, very good. Plus. Okay, very good. Okay, keep it down. Yes, go on, Hari Mahesh. Did you get it? Show me. Okay. Fine, go to the right hand side. I mean left. Okay. You have not written for product. I want for product also. Yes, Rushti. What is it? Want to show me your book? Okay. Okay, very good. For the product side, yes, it is positive, correct? It is not clear. Okay, yes, Yazira. Yes, Vishnu, just a minute. Okay, very good, Vishnu. Shrutika. Muttu, am I audible to you today? Your camera is on, mic is off, everything is off. Okay. Okay. Okay, very good, Hari Mahesh. Yes, come on, correct yourself if everyone has got it correct. But look over here. 6, I can write it as 6 is in the reactant, so minus 1 by 6 del concentration of H plus with respect to time. Similarly, it is equal to again now 3 that will come in the coefficient, but this time it is positive. Del by concentration of Br by del T by del T is equal to again 3 it is there, so 1 by 3 positive del concentration of H2O by del T. Is it clear, everyone? Come on, yes, yes, in the chat box. Is it clear? If it is not, please say no. Just because I am saying yes, yes, does not mean you have to say yes. Okay. So whenever we use this triangle, no, so generally it means we are talking about average rate. Okay. Whenever we use the triangle, no, generally it means we are talking about average rate. Okay. Should I give you one example? Okay, sorry. Should we do an example? So let us do an example. Just a minute, everyone. Just a minute. Is it visible? I know it might be little bit blur, but is it readable? Go on, try to read it. Might be little bit blur because I have taken it from the reference book. Right, come on, if you want it. I'll put it one more. Is it fine now? Yeah, better? Those who have specs? Okay. Was a personal attack. Those who have 4 eyes. It was. Come on, Vishnu, this is not dark humor. We have only, yeah, we have Jyotsna and we have Hari Mahesh who has specs. Chalo. So let us do this. Let us try to do this. Yeah. Decomposition of N2O5 is given. As I told you, N2O5. Yeah. Decomposition of N2O5 is given. This is your moderate reaction. Okay. So they have given you, if during a time interval the rate of decomposition of N2O5 is given, read the question carefully. Rate of decomposition of N2O5 is given. Okay. Then what else is given? Yeah. What else is given to you? Nothing. What will be the rate of formation of rates? Huh? They have asked rates. Rates of formation of NO2 and O2 during the same interval. So go ahead. First thing you should write is the, with respect to this, write down the complete rate of reaction. Come on, go ahead. Noel, Hari Mahesh, Parikshit, Jyotsna, Guptu, Vishwanath, Akash. Write down first with respect to the reaction. With respect to the reaction, come on. Write it down, the rate of the reaction N2O5 gives 2NO2 plus half O2. Now I want everyone to write it down and show me the book. Come on, go ahead. Write it down and show me the book. Okay. Yes, Parikshit, you can show. Parikshit, why is your camera not visible? Where is Parikshit? The Parikshit, you have some internet issue or what? Before showing it to me, no, I have like 18 to 20 people in front of me. Just click on the raise hand option so that. Wait, one by. Oh my god. Okay, Noel. Okay, just a minute, Noel, just a minute. Very good, Noel. Perfect. Vishnu, just a minute. Okay, very good. Who was it next? Jyotsna, yes, Jyotsna, go ahead, tell me. Just a minute, Jyotsna. Okay, very good. Who is this next one? Srishti, yes, Srishti, go ahead, show me. Okay. No, go. You are showing me some wrong things. Okay, perfect. Very good. Yeah, okay, so over here, everyone, what will be the rate of reaction again? Minus del concentration of N2O5 over del T, correct? Over del T is equal to 2 will go into the coefficient, the denominator, that is 1 by T, 1 by 2 del concentration of NO2 by del T. And what will be the coefficient over here, everyone? What will be the coefficient? Yes, it is 2. Vishnu, you have like only one special character as a question mark or what? Behind every simple answer also there is a question mark. 2 del O2 by del 2. What? There shouldn't be doubt. 1 by 2, if you take it in the denominator, 2 will go up. No? Common sense. Yeah. So what is given to us? Wait. What is given to us? The rate of decomposition of N2O5 is given to us. N2O5 is given to us. Yeah. So rate of N2O5 is given to us. So N2O5 by del T is given to us. Okay. So everyone, if I compare this two, okay, if I compare this two for NO2, yes, enough data, that's it. See, everything is equal. No, look over here. For finding out what we have to first find out NO2. So first to find out NO2, I'll consider this two. Okay, look over here. To find out the NO2, I'll consider this two. Now, I do not want half NO2 by del T. Understand that. I do not want half del NO2 by del T. What I want is a del NO2 by del T. Are you getting it, everyone? I want the rate of decomposition. Are you getting it? I want, the rate of formation. I do not want the rate of formation of half NO2. Are you getting it? Yes or no? So, over here, that 2, what I'll do? I'll multiply that 2 to this side. Correct? I'll multiply that 2. Yes, correct. So, 2 multiplied by the value what you have for this. So, N2O5 by del T, we know it is 2 into 1.8 into 10 to the power minus 2. Yes, and do not write negative. That negative is just for your understanding purpose that it is decreasing. Yeah, do not write negative. Yes, what is the answer over here? 0.9. How it come 0.9? You do not have to divide, Vishnu. Why did you divide? The other one you are saying about. Actually, the other answer you are saying about. For row 2, correct? Over here it will be 3.6 into 10 to the power minus 2. Is it clear, everyone? Parikshit, it is 0.0036, no? 3 decimals. Okay, not 0.036. Is it clear, everyone? Come on now, tell me for O2, come on. Similarly, compare O2 also. Similarly, compare O2 also. Yes. Similarly, compare O2 also. Correct. Very good, Noel. Very good, Parikshit. Very good, Vishnu. Jyotsna. Hari Mahesh. No, Hari Mahesh. How it can be 3.6 again? Over here, 2 was in the denominator. Over here, 2 in the numerator. So again, if I compare this and this, Hari Mahesh. Yes. Write it down separately. If you feel that it is getting complicated, write it down separately. Okay, what do you want? You want just del O2. Very good, Jyotsna. You just want del O2 by del T. You do not want that 2. Yeah, 1 by 2 minus del N2O5 by del T. What? Not that complicated. Come on. Okay.